Okay. So once again, page 6, table 1.4, metric prefixes. Please either copy it or memorize it. Copy it or write it out. You'll need it for quizzes and tests, okay? So that would be good. So this calculus in 2 weeks doesn't mean that we're starting calculus 2 weeks from now. It means we're going to get through calculus in 2 weeks. Just the basics, okay? Just the basics. And we'll go from there. You can move this. You should be able to move it, shouldn't you? We will have technical issues for a while, I guess. Okay, let's start with a very fundamental idea. And that is slope. And it doesn't work. Why doesn't it? Okay, coach, help me out here. Why isn't it working again? Dear. Everything I see is plugged in. Oh, gas and bells. Here we go. It's all good. What's happening?
Same thing.
Doesn't right. Everything's plugged in.
Oh, it's something's not plugged. Is your
Everything
there's
is
the
there as far as I can
USB.
tell.
This light should point
Yes, it should. I remember that now.
Now it should work.
Now it should.
Yeah.
Thank you.
So if this light isn't on or if it's red,
off,
just
right.
unplug and plug back in.
Okay. So,
Oh, and I figured out how to make. I can change your pen in a couple periods or whatever.
okay. Slope. We all know what slope is, right? Usually designated as m equals change in y over change in x. Here's your delta y. Here's your delta x. Right? And it doesn't matter what 2 points I put on the line, the slope will be constant. Straight line, constant slope. Okay. So, what if we don't have a straight line? Of course, slopes can also be negative, right? They can also be negative. And if I could just see the screen, we'd be in good shape. They could also be negative slopes, but I'm not going to show that now. But you got the idea. Not a straight line. So if I pick 2 points, here's my change in x. That is my change in y. Okay. But as you can see, if I move this point up here, the slope will change because the change in x will change, the change in y will change. So curve not a constant slope. Okay, does everyone believe that? Right? Everyone believe it's not a constant slope if you have a curved line. So what to do? What to do? So what we can look at here is maybe, oh, I like that. That's so much fun. want that, do I? I want to delete this. Forget that slide. Let's go to a different slide, shall we? I think we will. Let's go here. Okay, I guess you got to close out and then go back in. That makes no sense. And we'll do our Y here and our X here. And here's my curve. Now here's the trick. Okay, we can visualize the slope between those 2 points. Or we could. Now what happened? Well, let's take point A while it's on the board and move it towards B. Make that A prime. Slope changes, right? Gets steeper. Move it even closer. Call that A double prime. Slope gets even steeper. The point is that the slope is changing. Changing slope. Okay? Well, if that is the case, what can we do? Well, let's try something here. Our little line again here. Put our graph back up here. Y and X. And here is the trick. Let's skip this slide again. We'll get used to it, guys, don't worry. Somewhere along the line, we will get used to it. Put our Y there, our X here. Now here, let's take that same curve. Bring those 2 points together so that they coincide. So that's point A and point B. There is a line. A very good line. That line is called the tangent line. And that tangent line gives a slope at that X value. Newton saw this back in the 1700s. Not a bad idea. Now, once again, the slope is the change in Y over the change in X. Unfortunately for us, the change in X is what? From A to B, what's the change in X? Points are the same. They're at the same point. What's the change in X? 0. Thank you for being awake. 0. This causes a problem because we cannot divide by 0. Mathematically absurd. So, but not to fear, Newton is near. Not that I'm Newton, but here's what we got. We got a limit problem. Anyone heard of limits? Huh?
Yes.
So the limit as x approaches a of f of x is equal to f at a. So as those 2 points get closer, the change in x gets what? Closer to 0. And so it's a limit. What number is that fraction getting closer to as x gets closer, or the change in x gets closer to 0? Example, limit as x approaches 6. That's a 6, by the way. Of 3x plus 1. That's equal to 3 times 6 plus 1, and that is going to be 19. The limit as x approaches 10 of 1 plus, I didn't want to write that, did I? No. 1 plus x squared, limit of that. It's 1 plus 10 squared, or 101 Dalmatians. So limits get a little more involved, but we go with simple limits here because I'm kind of simple-minded. Questions? Moving on. Coach, this is too easy. So how are we going to define this slope now? We've already defined it as the change in y over the change in x. But for our purposes, what's y doing? It's going from initial value to a final value. So the initial value, or the final value, is f of x plus delta x minus f of x. Would that not be the change in y? Whatever the initial value was for x, add on, not subtract, add on delta x. So that's the new value for y. Subtract away the old value of y, f of x, or f at x. That represents change in y. But we need to change in x. Well, that's simple. That's just the change in x. But we can't let the change in x be 0. So we have to perceive this with the limit as delta x, approaches 0. This is the mathematical definition of the slope of the tangent line. The math definition of the slope of the tangent line. Know it, love it, breathe it, live it, because this is basic. It all goes back to delta y over delta x. With me? In about 2 or 3 weeks, you'll get to this in calculus. So keep all this under your hat. All these little things we're talking about now, they'll spout off in Mr. Gastenfeld's class. If we know that, we know part of the 2 weeks of calculus that we need to know. Because now it becomes just an issue of doing it. This actually gives you the equation for the slope at any point. So if you want to know the slope of the tangent line at any point along the curve, you do this. when we do this, we say we take a derivative. Take a derivative. Which is symbolized by many ways. F prime of x dy dx. These are differentials. Dy means small change in y, dx means a small change in x. Or we could just say f prime or y prime. These are all ways of indicating the derivative with respect to x. It's a lot to grasp at one time, but we go home and we do a little looking and we find that this is not too bad. Let's do an example, shall we? F of x equals x squared. Find y prime. Start with the definition. Y prime is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now that delta x in the bottom cannot be 0. So what has to happen? Delta x has to cancel out somewhere along the line. So now it boils down to a lot of algebra. If you know the basic math definition of the slope of a tangent line or the derivative, then you just do algebra. And the trick is this must cancel somewhere. If not, you divide by 0 and that can't happen. Here we go, f of x plus delta. Okay, so that's x plus delta x. Wherever I see an x, I put in x plus delta x. It's got to be squared minus what? X squared. And this is all over delta x. This is why you had to stay awake during Mr. Lover's class. All this algebra stuff. Well, if we take x plus delta x squared, we're going to get x squared plus 2x delta x plus delta, the quantity delta x squared all over delta x. And I left something off here, did I not? Can't do that. When you get old, your mind goes. Limit. Wonderful. Yes. The limit as delta x approaches 0. There we are. Now we're all good. Now, let's see. Can I pull this down somehow?
You scroll on the left side of the scroll.
Scroll down? Sure will. Or scroll which way?
You need minus x squared.
Minus x squared? Do I need minus? Yes, you are so right. I knew there was something missing here. Why did I know that? Why did I know that? Because I saw the delta x wasn't going to cancel. As soon as I saw that, I know there's something awry. As Shakespeare would say, there's something rotten in math land. Does it work? Bingo. Bingo. Volio. So now I'm left with limit as delta x approaches 0 of what? 2x delta x plus quantity delta x all squared. And that is it, because the delta x's will cancel out. Pull them out in front, Bingo, they cancel, and we're left with that. Okay, now what happens to this here? Did I leave something off anywhere?
You're still over delta x.
And we're still over, well, we shouldn't be over delta x, should we?
You didn't pull the delta x out.
Well, I did that in one step or one step. You see what I'm saying? I did that in one step. I'm looking here to see what we got. Oh, this delta x here was factored out, wasn't it? Sorry about that, gentlemen.
And also the last delta x should not be delta x.
And that should not be delta x either, which is a good thing. Okay. Thank you, great people, for staying awake. So there is,
You still have a plus delta x.
do I have a plus? I shouldn't have a plus delta x.
Because you have delta x squared.
But we factored it out.
But you only divided by one delta x. Delta x.
No, look, this is 0. So I could just look at, what was this here, 2? Yes, I could just look at this and pull out an x, right? For a delta x, pull it out, right? That leaves no delta x here, it leaves us a delta x there, one up, right? And this delta x out here will cancel that delta x.
Yeah.
And so what I'm left with is what? 2x plus delta x, right? Right. The limit of that. Now, when this goes to 0, what happens to this?
That's 2x.
Just becomes 2x. And there is the derivative of that function I just gave. So if I want to know what is the slope of the tangent line at x equals 1, the slope is 2. Slope of the tangent line at 5 is what? 10, and so forth. As x gets bigger, the slope gets steeper, which makes sense because if you look at f of x equals x squared, that is a parabola, right? Graph is a parabola, and so we know that the slope has to get larger as we go. Sorry for this bunch of moves. See that? So here's our answer. A little bit of algebra. Example. Let's do f of x equals, oh gosh, x squared minus x plus 5. And we want to find y prime. Start off with y prime equals the limit as delta x approaches 0 of x plus delta x squared minus x plus delta x, not squared, plus 5 all over delta x. Once again, the delta x must cancel somewhere along the line. So this becomes the limit as delta x approaches 0 of, again, x squared plus 2x delta x plus the quantity delta x squared minus what? X minus delta x plus 5. Wow. Over delta x. Be sure not to put all the pieces in there. So y prime now will be equal to we're going to have what? We can factor out a delta x, can we not? We can factor out a delta x, so let's do that. The limit as delta x approaches 0, We're going to factor out delta x, leaving me with what inside? X squared plus 2x plus delta x. We'll take one of those out of there. Minus x. And this is gone. Plus 5. This is all over delta x. Agreed? I just factored out a delta x from each term ahead of delta x. Because what happens? Cha-cha. That happens. Which is a good thing. The limit as delta x approaches 0 of what's left on top? X squared, come on, x squared plus 2x. That delta x is gone, right? No, we still got that in there. Delta x is still there. Minus x plus 5. And it's no longer over delta x, so that's gone. So the question becomes, what happens to the numerator as delta x approaches 0? Well, y prime equals x squared plus 2x. Is that right? I think we got that right. This is a 0, right? Minus x plus 5. Check it there closely. But the delta x go to 0. Now they can go to 0 because there's no delta x down here. That's why we got to get rid of the delta x. So that is the derivative of that function. So if you want to know what is the slope of the tangent line at x equals 1, it's 1 plus 2 is 3 minus 1, 2, it's 7. So y prime at 2 is equal to 7. So that's the slope at that point. At any other point, it will be different. Are we okay? Yep. No, it could happen.
I got y prime equals 2x minus 1.
Oh, you mean this one here? Oh, here. Here. Well, let's look. X plus delta x squared minus x plus delta x plus 5. There. Square this, you're going to get what? Where's that at? X squared plus 2x delta x plus delta x squared.
Add the minus f of x.
What now?
Write the minus f of x.
The minus, did I forget that again? This is what? This is just minus f of x, which is what? Minus what? Minus x squared. Thank you very much. Not on my game today. This would be a plus x, and this would be a minus 5, right?
Right. Yeah.
Oh, someone's awake, not me, apparently. Not me, apparently. So where do we go? I guess we can go up here. I'm assuming that is wrong. You got the down here. And I got to subtract this away here. Here, why don't we do this? Why don't we just erase this line here so we don't have such a mess? Yeah. Okay, we just don't have such a mess. Okay, there we go. So f prime of x is going to be equal to x squared. No. It's going to be equal to, once again, what's it going to be equal to? It's going to be equal to the quantity x plus delta x squared minus x plus delta x plus 5, right? Minus this, so that's going to be minus x squared minus 2x plus x minus 5, right? And that's all over
Minus x plus 5.
is there a plus 5 in here too? Yes, there is.
I don't know where you
Well, here, what do you have? Here's this. No, that's not right. X plus delta.
x plus delta x and then minus f of x, and this is
Let's
f of
start
x.
again. Jen, I'm sorry. I need to get more sleep. This is why we f prime of x squared plus delta x, right? What else we got here? Plus 2 times x plus delta x, right? Well, that's y prime. You know, I should just give up right at the moment. Here is the original function, right? Bam. X plus delta x, we got to square it, minus x plus delta x plus 5 minus what? F of x, which is minus x squared plus x minus 5, right? And this is all over delta x, so we got to put the limit out in front. Limit as x approaches 0. Now we got to do some math here. This is going to be equal to the limit as x approaches 0 of x squared plus the quantity delta x squared plus there's going to be a 2x delta x in here, right? Minus x minus delta x plus 5 minus x squared plus x minus 5. This is still got to all be over delta x. Do we agree to that point? Because at this point, we just got to start canceling things out. Oh, what happens here?
X squared go away.
The x squareds happily go away. Those are gone. 5s go away, right? And that's probably everything that goes away, right? That's everything that goes away. So now we're left with f prime of x equals the limit as delta x approaches 0. What's left in the numerator? What's left in the numerator? Delta x squared.
Oh,
Did my x's go away? Yes, they go away too. I'm too close to the board. Okay, so now we got what? Delta x squared, right? So we got the quantity delta x squared plus 2x delta x minus delta x. This is all gone. Thank God. And this is all over delta x. And I think at that point we're okay. Now what do? We got to factor out, right? Factor out a delta x in the top. See what happens there. So f prime of x is equal to the limit as x approaches 0 of, we can take a delta x out up top, leaving me with what? Delta x plus 2x. I don't know why I put that in there. I didn't have to put that in there. Delta x. Oh, come on. I think I should just give up. We're going to take a delta x out, which is going to leave us with what? Delta x plus 2x. Is everything else canceled out here?
Minus 1.
Minus 1?
Yeah.
Where do you see that at?
If you
Minus.
take out the delta x and you left with 1,
Where is that at?
the minus delta x.
When put the delta x
Okay, we got minus, thank you. So we got a -1, where am I going with this, right there? And this is over delta x, thank God, those cancel. Now the limit, as delta x approaches 0 of that mess, is what? 2x minus 1, right? And if you wanted to know what f prime of x equals, when x equals 2, what do you get? 3, right? So the slope, you want to call that the answer, that's the answer, but here is a specific answer for the slope when x is equal to 2. Sorry about that, it was a mess. Okay, now here's the problem. I can see this looming. F prime or f of x equals x to the 100th power. Find f prime of x. Is that a problem?
100x.
Huh?
Isn't it 100 times x to the 99?
What is it?
100x to the 99.
That is right. You've read somewhere. It is, but if you used our definition, you'd be here till the cows come home. You'd have x plus delta x times x plus delta x times x plus delta x times x plus delta x, all the way out to the 100th factor of x plus delta x. This would be indeed a mess. So, as my friend Jackson says, the answer is 100 times x raised to the 99th power. That's not easy to see right at the moment, but that is indeed the answer. Mr. Lozelle? No? Dominic Dolphin. Andrew? See? Andrew? Alex, Andrew, Alex, Jackson, Dominic, Jackson, Andrew, Alex. Well, now that I've screwed this all up today.
We were talking about homework.
Oh, yes, homework. So homework, does anyone have the syllabus signed yet and back? We could take that. Homework, if you read there, will not be graded. You'll be given the answers ahead of time. You'll be given the odd problems at the end of the chapter, or you'll be given the answers on a handout. It's up to you to do the homework, get the correct answer, and if you don't, you ask us at the beginning of the next class to go through that with you, okay? And that way, you must do the homework. Okay, you must do the homework.